Hi, Vicky.
Hey, Shane.
Have you heard about these giant spiders that are coming to the DC area?
No, no,
No?
no. What
Oh,
it?
g- oh goodness. This
What
is
is
so
this?
exciting. Uh,
Giants like tarantulas?
no, so they're called Joro spiders, Joro spiders.
Spiders.
I just did a quick Google search, and there's headlines like "Giant spider heading to the East Coast is good news for agriculture."
Oh,
Juro spiders likely to head beyond Georgia. Yeah, they're going to be coming to our area.
but
Um,
they're already in Georgia?
yeah, they're going to be everywhere. Let's just put it that way.
So,
Um,
okay. So I feel like murder hornets. There was a lot of hype around that, but then luckily, I feel like, at least in my personal life, never saw much of a murder hornet.
yeah.
So I'm definitely
So
going to see these spiders.
almost certainly, yeah. So the murder hornets were out west, and they're actually
Oh,
really like
okay.
murder hornets are really bad. They'll mess your day up. The Juro spiders
Yeah.
are big. They're about the size, like with legs and everything. They're about the size of your hand, like the palm of
No.
your hand. Yep. But they are venomous. But they're not gonna. They probably won't hurt you. But I think we'll have to add some addendums to this. I think
You
they fall from the sky.
Okay, you said, but they are venomous. Like, you're supposed to say, but they're not venomous.
I mean,
And
a
they
lot of
don't
things
fall
out
from
there
the sky.
are venomous. All
I
right.
don't like
Well,
anything that you're saying.
they balloon. They don't parachute. Yeah, I'll just send you some articles. It'll be really great. We're gonna
I'm not
learn some
reading
things about
them.
ourselves. No, it'll be fun. So last year we had the cicadas, which were
Yes.
just more annoying than anything. I
Those
think
were
my home
fine.
was
Yeah.
actual ground zero. This year we're gonna have spiders.
Okay. I can't. I need to leave the area.
It'll be fine. We'll get through it. I swear.
Okay.
All right. Science is fascinating, but don't just take my word for it. Join us as we hear stories from scientists for everyone. I'm Shane Hanlon.
And I'm Vicky Thompson.
And this is Third Pod from the Sun. So Vicky, you're not stoked about this? Did
No.
I ruined your day?
I'm not Team Spider.
Yeah. Well, I mean, a little bit of more reading. Yeah, venomous, but like probably won't bite you. And if they do, it's no worse than any other spider bite, which is still pretty rare. There will be a bunch of them, unfortunately. So look out for webs and spiders, like at big honking spiders at eye level.
Oh.
And it'll just be something that it'll be a shared experience, Vicky. Life is all about sharing experiences.
Something
And we
to
can
look
share this
back on.
together.
Yeah, something to look back on. Okay.
So we're talking about those huge spiders coming to DC for a reason, not just to freak people out. Today we're going to be talking about the emergence, millions of years ago, of a pretty diverse group of animals that don't actually include spiders. To tell us more, we're going to bring in producer Devin Reese. Hi, Devin.
Hi, Shane.
All right, so before we get into it, what are your thoughts on the giant spiders?
Yeah, even as a biologist, I am not sure I want to have one of those crawl on my face.
Yeah, biologist here as well, and I personally agree with you. But luckily, we are actually not here to talk about spiders. What are we here to talk about?
Today, we're going to hear from Hans Sues, who's going to tell us about the geologic period called the Triassic. That's the one right before the Jurassic, so the Triassic started like 252 million years ago and ended about 201 million years ago.
Okay, so for reference, this is like Jurassic Park, but earlier in time, so Triassic Park.
Well, Hans is actually the best person to answer that question, but I'll give you a hint, which is that dinosaurs showed up way before the Jurassic, along with a lot of other weird creatures.
I mean, okay, in all fairness, I think T-Rexes are pretty weird with like their big heads and their little hands. I'm miming. I wish people could actually see this right now. So I'm really stoked to hear this. Let's get into it.
Hi, I'm Hans Sues. I'm senior scientist in the Department of Paleobiology at the Smithsonian's National Museum of Natural History. And I'm in charge of non-mammalian vertebrate fossils.
And we're going to be talking today about a particular era, about the Triassic. Mm-hmm. Do you specialize in that era or do you work across?
I became interested in the Triassic that in group after group that I looked at, the key events in the early evolution and sometimes the origination of the group took place during the Triassic. So the Triassic, in a way, is really the time that modern ecosystems and most of the dominant modern groups of animals on land and even in the oceans come into being. And so it's a really interesting period. Strangely, however, when you sort of do an interest scale for geological periods, the Triassic has gotten much less attention than a lot of other geological periods.
And I've heard it described as sandwiched between two major extinction events.
In that respect, it's actually unique because it follows the largest extinction that we had in the history of life during the last 600 million years. And it ends with a major extinction of life, both in the oceans and on land, about 200 million years ago.
So the Triassic started with the biggest extinction event in the history of life on Earth. We're always hearing about the extinction of the large dinosaurs after the asteroid hit, but not so much about this earlier extinction.
And this extinction that started the Triassic, it was more severe, and it was a couple 100 million years earlier. So I actually asked Hans, what changes did this end Permian extinction cause?
In the oceans, there was like an enormous extinction. Many major groups disappeared, and by some estimates, anywhere between 80 and 90% of species disappeared. On land, the extinction was far less significant, contrary to what is written in particularly a lot of popular books. But the important thing that happens on land is that a group that are called stem mammals or therapsids, which were sort of the precursors of our own class mammals, they actually had huge losses at the boundary, particularly among their plant-eating forms. And so as we go into the Triassic, the diversity of this group has been enormously reduced. And what happens at the same time is that true reptiles suddenly diversify like crazy. And since this is sort of the beginning really of the Mesozoic as the age of reptiles. And along with this, and that's sort of one of the fun things about the Triassic, is that there are all these really strange and unusual animals that only existed during the Triassic and vanished at the end or towards the end of the Triassic. And so this is sort of an interesting biological conundrum. Why are they there?
So if I were to go back to the Triassic, would I recognize any animals as, representatives of the groups we see today? Would any of them look familiar to me?
Well, there would be some animals, but I think the majority would be, even from groups that are now still represented in our living ecosystems, many of them would look utterly strange. But you would see lizard-like things, you would see fish that you would recognize as belonging to major groups that are alive today, for instance, lungfish or little coelacanths. But then there are these other things like phytosaurs, even though they superficially look like crocodilians. When you look up closely, you see this difference, particularly in the shape of the head. And then there are lots of things like the Rauisuchians, the heavily armored Aedosaurs, which were these plant eaters that had their entire body in this cuirass of bony plates. Those were all things that would be utterly unfamiliar. It just would be like, you might as well gone to another planet with life. It just would be so utterly alien.
So can you tell me about some of the odd fellows that you have discovered from the Triassic?
Yeah, among the odd fellows I've discovered, there's an animal called Pteraturpeton, which comes from late Triassic rocks in Nova Scotia, Canada. And imagine an animal that has a very long, sort of very narrow skull with a huge beak up in front, at least no teeth, so it was probably covered by beak-like material like in a bird. Then 2 rows of upper teeth that are like little molar teeth, occluding against 1 row in the lower jaw. A skeleton that's very robust. It has hands and feet with these enormous blade-like digging claws. And it is part of a lineage that existed during the Triassic called Trilophosaurs. And these animals were very diverse during the Triassic. I just found a new one from the Middle Triassic together with a German colleague. So these animals were around for most of the Triassic, very, in some ways, like Trilophosaurus, the best known genus, is very lizard-like. In fact, it's sort of thought that they probably were like big iguana lizards that sort of clambered around in trees. They were all plant eaters. They had specialized dentitions for just that. But again, you look at these and they're just, while they're superficially perhaps a little bit like certain lizards, they're just, sui generis when you look at the skeleton.
So these things are like lizards with beaks.
Yeah, they have molar-like teeth in the back and then beaks on the front of the snout. Then another bizarre animal, perhaps my favorite Triassic animal, is called Longisquama. It's just known from a skeleton, a partial skeleton, and some impressions from the late Triassic of Kyrgyzstan in Central Asia. And imagine an animal that looks like a little lizard, has sort of a chameleon-like head, and then has these strange, long, scale-like structures running along the back. Each scale looks basically sort of has the outline of a hockey stick, and it's sort of, some people think, very feather-like, but it actually has more sort of heft to it than a feather. And nobody even knows what it is related to. We know it's a reptile. We can even say that because it has two holes in the skull on either side behind the eye socket, that is a diapsid reptile, the dominant group of reptiles. But there it ends.
Okay, so you say the scales are shaped like hockey sticks, but are they cylindrical?
Yeah, they're cylindrical. They have this sort of strange roughened surface with these sort of little undulations running across it. And they obviously had some kind of sort of spongy interior. It's a little bit like some lizards have, like for instance, green iguanas have these scales on their neck and back that are sort of rather three-dimensional. When you sort of cut them through, there's sort of spongy tissue in the center, something like that. And what it served for is anyone's guess. Initially, somebody suggested that there were perhaps structures for gliding, but that's not the case because there's only one row of them. So you need two rows to have an effective sail. And also they weren't in any kind of sense movable. They have soft tissue attachments to the backbone.
Well, you did talk about experimentation. So glide, plop.
Yeah. Plop. There was one really interesting group that did glide very successfully. They're called Kuniosaurs, and they're only known right now from Great Britain and from New Jersey. And these animals are really interesting because they have these super long ribs that they could fold out, and kind of like the gliding lizards of today that you find in South Asia, they were using them to support huge membranes along the side of their body. So these animals could actually glide. And of course, this is at the same time that you get also the first active flyers, which are pterosaurs, the group that includes pterodactyls.
And you talked about the Triassic being fundamental in establishing the major groups that we see on Earth today. Mm-hmm. So when you look back at the Triassic, then, are you really seeing the beginnings of the reptiles and the birds that, as you just pointed out, dominate today despite our mammocentric focus?
Exactly. Yeah, basically, when you think about important groups of animals today on land, lizards and snakes first show up in the Triassic. Frogs and salamanders show up in the Triassic. The immediate precursors of mammals show up in the Triassic. Dinosaurs show up in the Triassic. And of course, dinosaurs are the lineage that includes birds. And so birds basically show up in the Triassic, and so on and so forth. And among insects, flies, for instance, a really important group of insects, first show up in the early Triassic. We have beautiful fossils to document that. Most of the modern groups of beetles show up in the Triassic, grasshoppers of the modern type, and so on. All of these things show up in the Triassic.
So many things that aren't mammals.
Yeah, mammals get all the love. No love for the other creatures, I guess.
Yeah, I agree with you. And especially selfishly as someone who studied frogs and turtles. I have a special place in my heart for the creatures that folks don't always think about. But for Hans, in order to study all these different animals, he actually had the opportunity to travel all over the world.
So you're mentioning places all over the world. And so just tell me, in terms of your personal work, I mean, have you really gotten around the world to Triassic sites? What does your life look like in terms of your discoveries?
Most of my Triassic work has been in Central Europe and in the Eastern United States, but I have looked at Triassic deposits in Africa and Morocco, which is very well known for its Triassic rocks. And I've been, of course, out to the American Southwest, which for North American standards is sort of the gold standard for Triassic reptiles, places like Petrified Forest National Park. And I collaborate with colleagues in these areas quite extensively. The other area that's fantastic for the Triassic, but I haven't done any field work in so far, is in southern Brazil, the state of Rio Grande do Sul, and then in northwestern Argentina. And there you actually have layers and layers of rocks with different kinds of Triassic land vertebrates, various crocodile-line, archosaurs, the ruling reptiles. The first dinosaurs are known from South America, and the list goes on. So it's quite interesting.
So Morocco, Brazil, Argentina, I like what I do, but I really wonder if I should be changing my job.
Seriously. But I wanted to know if there are any Triassic fossils around here where we live.
So, for instance, if you drive through New Jersey, parts of Pennsylvania, you see these sort of dark or red rocks. And if you go up in Connecticut, it's all red, if you like in the area of New Haven. And those are Triassic rocks. And unfortunately, they're not as fossil rich as what we see in South America, but still they have an incredibly good geological record. And in fact, this is sort of slowly becoming one of the standards for measuring Triassic time, because the researcher, particularly my colleague Paul Olsen at Columbia University, and his colleague Dennis Kent, who's at Rutgers University, have been doing this fantastic work looking at changes in the Earth's magnetic field and then seeing how we can use that to date rocks, because the Earth's magnetic field every once in a while goes into reversed polarity, so that the North Pole becomes the South Pole and vice versa. Unfortunately, the Eastern US, even though I love to work here, is a really tricky place to do field work, because it's either people are sitting on it or it's covered with vegetation. So in the American Southwest, it's great. It's all deserts, and you just, to your heart's content can wander around and find fossils. Whereas here, I mean, I've collected fossils behind the dumpster of a local McDonald's. And in more than one case, I had a policeman asking me what exactly I was doing in a particular place, because no one in their right frame of mind would have been looking at it. And then I tell them, look, I'm finding fossils here. So get these puzzled looks.
Well, how in the world did you know to look behind the McDonald's for fossils anyway?
Well, because that was the only outcrop in that area of Pennsylvania where the Triassic rocks were actually nicely exposed. It's actually a historical site known since the 19th century. But, maybe 10, 20 years ago, they put a McDonald's right there. So because that was the place. So
I'm sure the cop was like, yeah, right, sir.
Yeah. Well, actually, one of my colleagues who was quite elderly, there's a very funny story about how paleontologists are treated by law enforcement, was looking for these tiny Cretaceous invertebrates in northern Germany, not too far, I should say, from a psychiatric facility. And they saw this old man crawling on the ground, picking up little rocks. And of course, they thought, somebody must have escaped this morning. So they arrested him and took him back, and turned out to be this innocent professor from the local university. He was like in his 80s by then, who was just collecting these little marine animals and had no idea why this was giving offense to law enforcement. So people always, when paleontologists wander around, either they're excited or they just get worried and, call 911.
Okay, so not in every case, but I guess this puts a different perspective on old men randomly wandering around outside.
Right. Some of them may just be trying to get a window into the past, like way into the past.
And speaking of which, you asked Hans if he would take the opportunity to get a bit more than just a window into the Triassic.
What if, in general, if you could be teleported, let's say just for 2 days, 2 days and a night, to the Triassic, would you go?
Absolutely. But I would heavily arm myself. Because Coelophysis was a predator, and it probably would have been unpleasant in a way that a dog can attack you. But there were some really huge animals around there. There's a group of animals called Phytosaurs that are very superficially similar to crocodiles, except they have their nose holes on top of the head, so basically sort of almost like a little U-boat with a periscope. And there is a group of Phytosaurs, a sort of subset that can attain enormous lengths. There's actually one on display now at the National Museum of Natural History called Smilosukis. And Smilosukis had a skull length of anywhere between 1 meter and 1.5 meters. And that's just the skull. So the whole animal would have been probably 10 meters, and it certainly would have been a more dangerous animal than any of the crocodiles that are alive today.
Was there something that happened in the early Triassic that kind of got this burst of diversification going? Was there anything in the climate or the geology that got things kick-started?
No, actually, it's interesting. The early Triassic is a really bleak period in the history of life because you had this major extinction, but the other thing that happened during this extinction was, because it was caused by like the supermassive volcanic activity, the climate was completely disturbed. So the early Triassic was a time when it was extremely hot and dry in many places around the world. So if you find life, it's generally low diversity, not many species around. And we're still sort of kind of puzzling what happened next, because as soon as you get into the beginning of the Middle Triassic, there's suddenly an abundance of animal and plant lineages. So were there perhaps refugia where things withdrew during the great climate crisis, or were there just really fast evolutionary change events? And we still haven't sorted this out, because the problem is that the early Triassic is only known in a few regions of the world. And so we have a very biased picture of that. Like, for instance, in South Africa, where much of the Permo-Triassic extinction discussion is centered for land life, the Permian is rich, diverse, with particularly all these stem mammals and early reptiles. But then when you get into the Triassic, the first thing you find is this stem mammal called Lystrosaurus, and there's very little except Lystrosaurus. Like, Lystrosaurus is so common in South Africa, you go out in a day and like in the afternoon, I've heard people finding 30 skulls of this. It's almost like picking up potatoes. Just in Germany, I just recently discovered that we had the first Rincosaurs, which are these very strange animals that were very abundant in the middle and late Triassic of the southern hemisphere, in the supercontinent Gondwana. And these were plant eaters, and had this sort of strange beak-like snout, and then would chew up their plant food with these batteries of teeth. They had an upper tooth plate, and then the lower teeth would sort of fit in like the blade of a penknife into this upper, and they would just grind vegetation. They could eat the toughest stuff around, the most fibrous vegetation. And yes, there was suddenly these little Rincosaurs in Germany where nobody had ever expected. And I'm just working on another animal with a German colleague, which is an early Archosaur-like animal. Again, something that we had no idea even existed. So it's paleontology sort of, it's very incremental. We just sort of, some idea, we form ideas based on what we know, but then as good scientists, we keep testing these assumptions and hypotheses. And very often, because of new evidence, we have to go back to the drawing board and come up with new ideas about what life was like at the time. So the question arises, how many groups actually did survive the end Permian extinction, yet left little or no record? Because that's always the problem. Paleontology is sort of an exercise in serendipity, because for large chunks of the geological record, there are very few exposures around the world. I mean, it's not to say that maybe someday when Antarctica has finally lost its ice cap, that we will find all kinds of cool stuff there. Or when we find new early Triassic sites, say in China or in parts of Africa, that there will be things in there that we can't even imagine.
So there may be lots of Triassic creatures waiting to be discovered, fossilized in places that we can't access because they're covered with ice or not on the surface of the Earth, right?
Yeah, I hadn't really thought about it that way. The paleontologists are finding a tiny sample of what got preserved, like the parts that are exposed. But still, so many weird Triassic animals have been found.
You know, I wonder what happened to all those strange animals towards the end of the Triassic.
It's interesting that the other side of the extension sandwich probably had the same kill mechanism that the beginning had, namely massive volcanic eruptions. We always think about extinctions sort of in terms of extraterrestrial causes, ever since people discovered that basically Cretaceous extinction, which wiped out all the dinosaurs except birds, was caused by an asteroid impact. So people think, oh, maybe all of these big extinctions are caused by this. And indeed, a lot of researchers who are not paleontologists have been running around the world trying to find impact craters that can be dated in order to explain these other extinction events. But the reality is, for the end Permian and also the end Triassic extinction, it's massive volcanic activity. Now, in the case of the end Triassic, it's very interesting because it does concern us here on the East Coast. Because basically, when Pangaea, the supercontinent, started slowly breaking up, the first major break that developed is the area that is now the northern part of the Atlantic Ocean. I mentioned this rift valley that formed between what's now Eastern North America and Europe and North Africa on the other side. And what happened was that this rift expanded and suddenly immense quantities of basalt lavas came up over an area of about 6 million square kilometers. In fact, this was the largest volcanic activity like that, even bigger than the one that caused the end Permian extinction. And basically all the way from what is now Greenland, all the way down to the Gulf of Mexico, down to Brazil, to West Africa. This was one giant zone of volcanic activity. And we have very good dates for those volcanic rocks. And this all happened within about 1 million years. So imagine this global event. The climate went completely to hell, because initially, after a volcanic eruption like this, you have all the sulfuric dioxide going up into the atmosphere. It comes down again as little droplets of sulfuric acid, which cool down things because they reflect the sunlight, just like volcanoes do today. And then after that, all the CO2 that has been spewed out kicks in. And so you go from an already warm world in the Triassic to something that's just like really super hot. And of course, that really affected ecosystems, both on land and in the sea, in extreme measures.
So to me, that doesn't sound like conditions under which really anything should survive. Yeah. It sounds like a living hell.
Yeah, no, it would have certainly been.
But obviously some things squeaked through, or we wouldn't be having this discussion today. So what squeaked through, and how?
Yeah, if you want to have a modern analog of what was going on, there's an area in Ethiopia called the Afar Triangle, which is a really desolate, boiling hot place, hardly with any life. That would have been what Eastern North America would have been looking like right then. But then the volcanism sort of started tapering off. There was still quite a bit of volcanic activity going into the Jurassic, but at the same time, you suddenly see a whole bunch of new animals showing up. The vegetation has changed, but new kinds of plants show up. So for instance, in the Triassic, you have all these ferns and conifers. And when you get into the early Jurassic here in Eastern North America, suddenly almost the entire vegetation is made up of these very hardy conifers that have really needles with very thick skins or cuticles.
Okay, so some conifers squeaked through, ones that were more fire adapted. And what in terms of vertebrate animals, what made it through, and why the ones that made it through? How could they have survived these conditions?
Well, of course, small animals can always get out of bad conditions like that by going underground. Just like today, mammals and lizards, most small species are burrowing animals or usually burrows of other animals that do burrow. Some animals survive because they're in lakes and rivers. And I mean, obviously there was water around. Otherwise there would have been no life at all. And so quite a few things can survive. The other thing, of course, is that the world is obviously not one uniform place. There would have been areas that would have been less affected, and they could have been then used as reservoirs for animals and plants from which they then could spread out again into the other now decimated areas to repopulate. But the really interesting thing is that there's this great competition between two major lineages of archosaurian reptiles. There's the line that leads to crocodiles, the crocodilians today, and the line that leads to dinosaurs, including birds. And interestingly, during the Triassic, we have the heyday of the crocodile-like archosaurs, like these Rauisuchians, the Aedosaurs, the heavily armored things, the Phytosaurs. But all of these disappear at the end of the Triassic, and they were really the dominant land predators before dinosaurs became the dominant land predators at the beginning of the Jurassic. Rauisuchians completely disappear, but dinosaurs, which already showed up in the Triassic, go through the transition without any known losses at all. So dinosaurs fared well. And one of the big questions that we actually right now are examining is a group led by Paul Olsen that I'm part of. We have some ideas now why that may be the case, but of course we now have to publish them and sort of get the input from the scientific community on this. But dinosaurs are a real success story, and it has been argued that either this was due to competition, that dinosaurs had somehow features that made them superior to crocodile-like archosaurs, or the other hypothesis, which I find a little bit more plausible, but it's very difficult to sort of test scientifically, is the fact that the crocodile-like archosaurs largely disappear, except the lines that ultimately lead to modern crocodilians, but that basically because all of these competitors disappear, you have new ecological opportunities, and dinosaurs just took advantage of them. So it wasn't some kind of active competition, but rather dinosaurs took over by default.
I can't wait to see that new paper that you're talking about. So, all right. So then if we're going to teleport you to a particular geographic region for you to spend the end of the Triassic, where do you choose?
I think I would go to what's now Argentina or Brazil, because that's far enough away from the worst of it. So.
All right. So for the end of the podcast, at least of this recording, we're going to teleport you like you requested to Argentina.
Actually, what I would most like to see would be one of those giant Rauisuchians, the top predators before the dinosaurs took over that role. And I mean, there must be, imagine something, this giant land crocodile-like thing with long legs. They had a very upright walk, same upright sort of narrow gait walk, enormous skulls with like some cases T-Rex sized teeth. And, that would have been a really cool sight.
I Googled Rauisuchian and also how to pronounce it.
Sure.
I want to be correct here. And the thing is wild. And here's the thing about seeing one. If you see one, they can also see you. And that is far too close for comfort for me.
Yeah, I would never want to be that close to it. Also, it walks, like the description of it walking upright, but it's like almost too human in that way.
Yeah, there's the fear factor and then the uncanny factor.
Uncanny, yes.
Something just doesn't look right with this.
No,
well, with that wonderful image in everyone's head, that's all from Third Pod from the Sun.
Thanks so much to Devin for bringing us this story and to Hans for sharing his work with us.
This episode was produced by Devin with audio engineering from Colin Warren.
We'd love to hear your thoughts on this podcast. please rate and review us, and you can find new episodes on your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next week. Cool. All right, one more.
Okay.
I'm just getting them all in Vicky. Like we're just.
I love it.
I'm getting this wonderful time with you.